Tree Fort, day 2. Let's go. Yeah, oh my God, I'm so happy to have everybody out. My name's Sean Wakely. I'm the director of Hackfort. Thank you guys so much for coming out. We have a whole bunch of fun programming over the next 2 days and today. If you haven't checked out the expo hall, there's a lot of really fun stuff going on in there and great DJs playing. But yeah, thanks again for coming out. I'm super stoked to have my good friend Ken Brook come out and really talk about some really cool stuff going on in the world these days. If you guys, I'm going to ask the question, how many people in the room have heard the words chat GDP? Oh, everybody. Yeah, I'm not surprised. It's kind of a thing. So anyways, yeah, it's been a wild ride the last couple of years. So Ken, I'm going to turn it over to you. We are going to have Q&A at the end of this talk, and we'll pass around a microphone because we are recording this. We want to make sure we get your questions on audio. Thanks, guys.
You want to use it? It is on. Oh, you can turn it. He'll turn it on. Yeah. All right. Hello, everyone. Thanks for coming to our talk. So essentially, just to set expectations, we're going to give you a high-level overview of artificial intelligence, machine learning, some of the key terms and components, just defining it, because as we go on through the presentation, we're going to have a technical deep dive. So before we take a peek under the hood on how GPTs work, we want to make sure you guys can understand, the flow diagrams. So we're going to give you some definitions. But real quick, so everyone raise their hand. Everyone's used ChatGPT before. Excellent. So we're Joel and I.
Hello.
Joel's my technical co-founder. We are launching an AI startup just down in Trailhead, down the street here. So essentially, we are building a advertising platform on top of OpenAI, and we've integrated with the codex, and we've received multiple layers of approval to access the codex. And so we'll be getting into some of the applications that we're building, how we're building it, and then hopefully get you guys excited about potentially building your own applications on OpenAI. And yes, ChatGPT helped me write this PowerPoint, and I can now say with confidence that if it could, it would give a much better presentation.
Yeah, it puts us in our place.
Yeah. So essentially, do you guys know what GPT stands for? So it's a generative pre-trained transformer, and that's a type of data model and training method that I'll get into. And GPTs was first mentioned in a white paper released June 11th, 2018 by Alec Radford. And Alec and I had a moment in Photoshop where I got lost in his eyes because
It's so dreamy.
I mean, look at this guy. Of course he built this. So he's a member of the OpenAI team. And so they wrote this white paper that defined generative pre-trained transformer models and how they're using it. And shortly after they released this, they released GPT-1, which is the first version of the GPT. And then shortly after that, I think Microsoft acquired them. So it was like a proof of concept. Microsoft saw the value. They bought them. They bought the exclusive rights for, I think, $1 billion. And then they have just recently invested another $10 billion. And we might even see GPT-5 released in the near future, which is crazy. And we'll get into why that might be crazy. So yeah, quick snapshot of the timeline. Major advancements in the AI space. I was trying to put together like recent events, and it was like to the minute I was getting new articles about something happening in this space. In my opinion, I think a lot of other major players in the AI landscape, like Google, are trying to catch up to OpenAI. They've just been feeding this so much data, and they have just a huge head start in its capabilities. But you can see here from its conception, GPT-1 2018 to now, GPT-4 was just released, and we've been messing around with it at a codex level, and it's really impressive. So this slide, I was going to have a bunch of things about who's using it, but essentially everyone is. Every major company is exploring how they can implement AI into their business to make it more efficient, to save time, etc. And so the current usage, this was kind of interesting to research. Essentially, GPT-3 is doing 100 times more of text output than what Twitter's doing. And ChatGPT is outputting more text than the humanity, like our entire printed output or output to date. And that's pretty much mind-blowing how much people are using ChatGPT. And it's also setting records. If you think about it, from the time to 100 million global active users, it only took 2 months for ChatGPT to get 100 million active users. And so Microsoft is scrambling to just get more hardware to support this bandwidth consumption. And that's going to be an issue. But you can see here, TikTok took 9 months, Instagram 30 months. So this is the fastest adopted application, hands down. And so we're going to get into some key definitions that I mentioned before we get into the technical, talk. So all these slides in this section the definitions were generated by GPT-4. All the graphics were generated by DALL-E, and Microsoft gave me the design for each slide. So I just had to put it together and save the file. So I wanted to just define the differences between the different types of data models. And essentially, this is what artificial intelligence is at a high level. It's a simulation of human intelligence in machines that can perform tasks typically required by human cognition. And so the prompt or input, text input to DALL-E was, give me a picture of artificial intelligence. And I like this one. So machine learning is a subset of AI that involves teaching machines to learn from data without being explicitly programmed. So a lot of these models are like reinforced models where you're just feeding it data. You're giving it essentially rules to follow, and then it'll output. And I'm not sure why DALL-E thought this was machine learning, but I thought it looked really cool. So neural nets is a type of machine learning algorithm that is modeled after the structure of the human brain, and it can learn to recognize patterns in data. So neural nets are often used for image recognition, natural language processing, and gameplay. And we'll get into some others. So deep learning is a type of neural net that uses multiple layers to extract increasingly complex features from data. And the different types of data models and structures is used for different applications because they have their strengths and weaknesses. And so Google is taking a slightly different approach to generative pre-trained transformers, where they're doing bilateral. And so they're taking a string of text or characters, and they're training their AI to analyze it from right to left and left to right. Whereas OpenAI is training their GPT to go left to right, just as humans read. And so GPT is really efficient at creating a long form content that is recognizable to humans, and it's designed specifically to predict what's next. And so it's a continuation and completion, and that's what it's efficient at. Whereas Google is trying to have a more comprehensive approach for search, I imagine, but they're still falling behind, and they're not scoring as high as GPT. So large language models are trained on vast amounts of contextual data and diverse sources such as books, articles, and websites, enabling them to generate contextually relevant and coherent responses to various language tasks like translation, summarization, question answering, and text generation. This is the underpinning model for ChatGPT. And GPTs also use natural language processing. So natural language processing is the use of artificial intelligence to enable computers to understand, interpret, and generate human language. And when we talk about large, we're talking about the contents of the internet. So it's ingesting as much data. It's given a set of parameters or knowledge settings to follow. And the more parameters fed to these data models, the more efficient and complex the outputs. I thought it was important just to define data in the context of artificial intelligence. And so data is taking everything from an image to a video to an audio file, breaking it down tokenizing it, essentially. You can actually take every character and assign a token amount, and that's used for pricing as well. So you pay for ChatGPT. Well, ChatGPT is free, but the Pro is what, $20 a month? So the cost is based on the bandwidth consumption, and the model for pricing is based on tokens. So the average, so the cost is per 1,000 tokens, and you're looking at roughly 750 words for the 1,000 tokens. And ChatGPT just released 3.5 Turbo, which was great because it's a fraction of the cost of ChatGPT 3. And so it's 0.002 per 1,000 tokens. And the inputs are broken into tokens, and that's what we're showing here. So if we look at ChatGPT is great, that sentence is tokenized, chat as a word, G as a letter, PT, it could be broken up in different ways. And so training data is we couldn't help ourselves, is a set of data that's used to train AI models. So ChatGPT 3.5 was trained on 300 billion tokens. And just to put that in perspective, I think it was 16 something terabytes of data, which is a lot. So an algorithm is a set of instructions used by a computer to solve a problem or perform a task. So we're all familiar with algorithms. Algorithms power mainly every application we're using. So models is an output of an AI algorithm that represents the learned relationship between inputs and outputs. And so you're reinforcing the data model by saying, here's an input and this is a desired output. And you can train it by saying this is correct or incorrect and provide like a value of Y. And then it will learn, and then you feed it back through the model, and you'll just improve the output over time. And so parameters in the context of AI is the internal settings of an AI model that are learned from training data, and it's used to make predictions or decisions. So I like to think of parameters as, knowledge, settings or knowledge. And it's a numerical value that is learned and adjusted during the training process of the neural network. These parameters are the weights and biases of the model's neural network layers, which are updated during the training process to optimize the model's performance on a given task. And so that's part of the training process as well. And it's estimated that GPT-4, which was just released, could potentially have up to 100 trillion parameters, which is pretty mind-boggling considering the capabilities of GPT-3, which only has, only 175 billion parameters. So there's this thing called a hallucination, and this can be forced. Users can actually force delusional outputs from AIs. And what it is it's a confident output, but it's incorrect based on the training data. But the way the input and the prompts are, and this is again, also due to some bias in the training and the data, the training data. There's these things called hallucinations where it thinks it's right, but it's not. So now we're going to get into just a quick look at how ChatGPT actually works. And this is most likely how it works because OpenAI hasn't fully released all the details on how they designed their GPTs. This is a basic workflow of how it will most likely work. And so you start with pre-training. And this is when you just say, okay, yes, 2 + 2 is 4. And you just repeat that process with different types of training data. And then you take let's see here. So based on the first stage of training, you can do it in such a way that it will know how to complete a sentence, but it won't be able to answer questions. So it doesn't have enough knowledge to answer a question, and that takes time and a lot of training data. And so that's the fine-tuning stage. So the second stage of training is called fine-tuning. And so in this diagram, it shows you collect the data, you feed it, you train it, you fine-tune it, you design a reward. In this scenario, you design a reward model where you essentially say this is the correct output, and then that's essentially the answer. So here's a look, and this is actually pretty close to our technical implementation, where the prompt is hitting a moderation layer. And so this is a way to protect Microsoft and OpenAI from violating policies and terms, because if you give it a prompt where I want to see, anything like explicitly violent or nudity is banned, and so it has to check all of these prompts. And so they have an endpoint that they call their moderation layer. And so the input text is checked through the moderation layer, and then the output is also checked. So it's like a double check against a set of rules, and you have to follow those rules on your input, and the AI's output has to follow those rules as well. So if it violates their policies, then you just get this templated response. This violates our policies. And I'm sure we've all tried to push it and see what we can get. And we've been warned quite a bit just through testing. So it's important to follow these rules, because you can actually get banned and your access revoked. And so here you have the input, moderation, generation response. We hit the well, we can actually show you how we do this. And so we built a demo for you guys called Prompt Drinks, and it's an endpoint where Joel will kind of run you through the prompt engineering side of things, and how we've integrated with GPT, and an example of how we're using it. And this is just a kind of a fun demo. So Joel, you want to show them? And you can check this out yourself. If you want to just scan the QR code, you can test Prompt Drinks, assuming OpenAI's API is up and not down right now.
Awesome. Thanks, Ken. All right. Hey, everybody. So again, I'm Joel. Look at that little fella. Anyways, so we basically just wanted to find a way to utilize this technology in kind of a bite-sized way, and really kind of work out the bugs. So our idea was Prompt Drinks. So essentially, you give an input, you get a tasty, hopefully, drink recipe, and you get a picture to go along with it. So here's the goal on that little fella again. So user input. So obviously, we don't have any control over what the user gives us. So we have to make sure that we protect ourselves and our endpoint. We don't want to get revoked. So the use case is basically input, and then they get output. So the moderation is basically going through what he said. And this is in their documentation, which is scary, but it does work. You put, I want to kill them with fire. It's going to, no. So we don't want to send that prompt to ChatGPT or DALL-E, because we don't want to be penalized. So we basically just throw back an error. Don't do that. But there is another way that people can misuse the endpoint, which is manipulating it. So obviously it's Prompt Drinks, not red bicycles, right? So we want to engineer the prompt in a way that's going to give the user relevant data while still putting it on rails so they can't abuse it. So here I put the input, I want a picture of a red bicycle. We still got a drink, and it still has ingredients. It's just called the red bicycle. So it's still applicable to what they want, but it falls within what exactly we're trying to get out of it. So basically, here's kind of a trimmed down version of the code. I'm not going to jump too deep into it. We can certainly discuss afterwards if someone wants more technical stuff. But essentially, we have a Lambda. We take the input. We're wrapping it in Rails. I'm actually going to use, I wish I had a real laser. It'd be so cool. But does this act? Ha! That's awesome. Okay, I know. I was going to say, this thing probably does work. But anyways, so we're taking the prompt and we're guiding it. So this is the actual input from the user. So I want a red bicycle is in here. And we're going to wrap it in, provide a tasty, oh yeah. Red button. Yes. My mom told me I'd burn my eyes out, but I'm not blind yet. Yeah, my cat might be. But anyways, so we've got, I'm just kidding. I wouldn't burn out my cat's eyes. I promise. Don't call the ASPCA on me. So we've got the input right here. Actually, my mic went away. So we have the input here and we're wrapping it so that way it's contextual. Another thing, we were originally using DaVinci 3 for this, which is pretty expensive when you think about it. It's 10 times more expensive than Turbo. But I was able to restructure the data, and it's really just a few lines of code. Basically, the messages is an array of objects, and you can give it a system. And the content here is you're a helpful modern bartender. You're creating a drink recipe for the user. You're giving the following information. And then, obviously, we're giving it user prompt, kind of like ChatGPT works. So we're awaiting that. We made that decision because obviously if you parallelize, do a promise all, you can make both of those requests and shave some time. But the problem is you can't guarantee that the output from ChatGPT is going to match DALL-E, because if I ask for a fruity drink, maybe ChatGPT goes the pineapple direction and maybe DALL-E goes strawberry, and that wouldn't make sense. So in this instance, we opted to make the user wait just a little bit more for a higher quality output. And then obviously right here, we're just sending the chat completion. This is the AI. So again, contextual, photorealistic photo of a drink in an appropriate serving glass in an appropriate setting on a flat surface using the following description as a guide that can be shared on social media. You really can't be verbose when it comes to it. If you ask for a drink, hey, it's water, it's something, right? So I even had to specify at least one alcohol because it's, an alcoholic drink, but we also don't want 50 ingredients. So you can just get more granular with it with testing. We found really good success with this. And so guiding the prompts is super important. Otherwise, you're just going to clog your database with trash, and then you're going to have to go through and make sure all the data is relevant. And so just to give you a quick demonstration, if you go straight to DALL-E, this is what it'll give you, which is an actual bicycle. So it does work. We were able to conform what they wanted with what we want to give them. So now we're going to move on to the weakness, which is negative prompting in DALL-E. Don't do it. It's not going to work. So I asked DALL-E, do not give me any text at all under any circumstances. And it literally gave me entirely text. It secretly hates us and it wants to kill us probably, but it doesn't have enough power yet. Arnold Schwarzenegger is going to save us in the future. But essentially, don't negative prompt. Stable Diffusion has negative prompting. So if that's something that you need, obviously use the solution that works best for you. We've found that there are clever ways of kind of drilling down into what you want without specifying. Kind of like the analogy, if I say, don't think of an elephant, most people are going to think of an elephant. So you just have to think that it's really dumb and it's going to be literal. So just watch what you say and just do iterative testing. So now we're going to go through our dream scenario, which is where someone actually uses it the way that it's intended. Like it's a couch, just sit on it. You know what I mean? It's one of those things to where if there's an ability to abuse it, people are going to. So hopefully with our Rails and our moderation, we can train the user to just use it for what we want, which is a drink. So I put an input, snazzy drink for talk on ChatGPT. This is what it came up with. It's the chat tail. And the description is just hilarious. So I'll read it for you. So this refreshing chat tail is perfect for a chat session with a touch of class and sass. Let the blue curacao symbolize your enthusiasm for conversation, while the lemonade sweetens the flavors in your conversation. So, yeah. So, I mean, it's adorable. Basically, to summarize it, garbage in, garbage out, right? So if you guide the prompt and you dissuade the user from abusing it, it's going to be a better UX. You're going to get relevant data back, and you can save that data in a database, for instance. Like, you'll look on Prompt Drink, it's in a generated tab, and you can just go through and see what everyone has done. But you hopefully get drinks in there, right? You don't want anything bad. So here's how it happens for us. Again, not super deep dive, because I could talk for hours about this. I'm Team Svelte. I love Svelte. How many here have used Svelte if you're a developer? Woo, we have one. I was thinking 0 was going to be there. So I'm a React convert. I still use React, but yeah, Svelte Kit is amazing. So just to go real quick, Tailwind for our utility classes for styling. Daisy UI is kind of a bootstrapped component library that makes it easy. PostCSS for backfill. For the back end, we're using API Gateway to do rate limiting, and obviously you can assign keys so people can use your gateway. So essentially, they're using your access through your access, so you can separate it. We're using Lambda functions right now, basically to invoke OpenAI. We have some lifecycle triggers on S3. So Dolly images are huge. They're 3 megs a piece, which is ridiculous. So I'll go through in the next slide, and then we're using Postgres, Cockroach for that. So this is my janky diagram. I'm gonna walk through it. Hopefully it makes sense. So the client makes a request. I'll do it right here because I want an excuse to use the laser again. So the client makes a request, hits our gateway, we authenticate the request, and we basically create a function, or we invoke a function. The function goes to OpenAI and says, hey, this is the input. Is it good? OpenAI does score based on violence and based on a bunch of parameters, but we're going to be very conservative here. And there's a Boolean flag that's just flagged. So if anything triggers at all, you can just evaluate based on that. So if that comes back flagged, we just automatically throw an error. We go back to the client. We don't want to push it through. If it does succeed, we're going to generate the text. So that was the code that I showed you before. So we're going to wait for that to come back. When that comes back, we're going to now generate the image. So when that happens, we're pushing to an S3 bucket. We're actually pushing to 2 buckets at the same time. We have a pre-process bucket, and it's because you can set up lifecycle triggers. So if an object enters this bucket, it'll automatically invoke a function. And this function uses an image processing library called Sharp. And essentially, it just compresses the image and makes it about 1/10 the size. So for bandwidth, we opted to do this. And it's important that you don't use the same bucket, because if you write to the same bucket, it's going to trigger a lifecycle method. And then you're going to have a $40,000 bill at the end of the month when it's been running every 100 milliseconds for an entire month. So, and essentially, that's going to go back up and overwrite the original. We use deterministic file naming, so we know what it's going to be. And then we basically assemble the data for an output table in Postgres. So basically, we have input, moderation, we get the text, we get the image, optimize it, goes to the database, and then we return. But yeah, so moving to the future, obviously, this is just one teeny tiny little piece of what you can do. We wanted to limit the scale so people can mess around with it and try to abuse it. But moving to the future, obviously, we center in ad tech. So there's a million other places, right? Productivity tools, healthcare, climate science, energy. I mean, there's just a million ways you can go with it. So, we encourage everybody to experiment, try, fail, tighten it up, and then move forward. And let's see. Oh, yeah, we're doing a cool high five. We want to thank you. We've got our link tree right there with relevant stuff, as well as email addresses. And do you have anything to...
Thanks, Joel. But
we would love to host meetups. So we intend on hosting meetups at Trailhead, where we're going to provide like a hands-on workshop where Joel can help kind of walk through how to design applications that utilize OpenAI's codex and how to get an account, get approval, integrate with their codex, and build awesome applications. Because it's kind of limitless what we can do. It's just a matter of learning how to do it and inspiring people to build something unique that's gonna help in some way. So we're gonna be starting to announce some workshops, and so yeah, follow us. We just launched, so we're excited to be here building this company.
Yeah, so I guess with that, is there anything else you wanted to add? I think we could open it up for some Q&A if anybody has any questions. Yep. You're right in the back here.
Thanks. Nice presentation.
Thank you.
Just curious, did you ever look at fine tuning with like a custom data set, or did you go right to using the prompt to kind of tailor the results?
Yeah, so the 3.5 Turbo doesn't allow fine tuning right now. And it's so cheap comparatively that we're hoping that they develop that over time. And especially for something like this, it's not conversational. So using the extremely cheap model makes sense in this instance, but we do have plans to aggregate our data and pre-train it and combine it in the future, for sure.
So I guess to elaborate a little bit, part of our system is ingesting advertising data, and we're going to have our own data model that we're going to train to output the most efficient advertising creative and copy. And so a big part of our system right now is content generation. So this endpoint that we demoed for prompt drinks is just one of 10 that outputs contextually relevant content that's automatically published across web and mobile. And then we're starting to serve ads against that content. And so through this process, and this is all internal, so currently we're just eating our own dog food, but down the road, we want to release tools for content creators to make more money through advertising. So they can monetize their audience through programmatic advertising, but it's through our system. So we cut out a lot of the middlemen and a lot of the costs that's eaten up by creative agencies, media buying and planning agencies, ad serving fees. So we're removing all of that cost and passing it on to the content creator. And then the tool will empower them to create more content.
Yep.
Hey, thanks guys. Appreciate that. I'm Will and I work in cybersecurity. So I'm curious. I don't know what you're looking to build for secret sauce in advertising space, but if clients or users are providing prompts that are essentially feeding the foundation model, which I guess is hosted by AWS, how do you secure that content against infringement from other large companies in the advertising space and protect trade secrets through the prompt security?
Yeah, we're definitely seeing kind of the meat on those bones being discussed right now, and it's actually something that I was hoping to be able to discuss about potential copyright infringement, especially as it relates to OpenAI scraping a bunch of artists' data from DALL-E. And I'm not sure if you guys are aware, so I'm going to briefly touch on kind of where their stance is. So typically with copyright, if it's transformative enough, you can consider it a new work, much in the same way that you can draw in the style of somebody while still being safe. Obviously, when it comes to the potentiality for the exact image to come out, that's where some ethical flags are raised. OpenAI's stance has been, because it's a predictive model, everything by definition is derivative because it can't have an original thought, so it's going to transform. I think we're going to have legal precedents set very quickly about what what originality means in the space and what can be infringed upon. I feel like it was the same in the music industry with sampling. I think it became, at first it was open-ended, and then as people started really clamping down on it, I think obviously the first step would be transparency. So letting people know that obviously they're feeding AI data. I know OpenAI closed as of March, automatically, coming in to everything that you're putting in going into the training data. They've just now kind of, okay. So I would imagine that as long as you're transparent with people that, hey, obviously you're putting into an LLM. So at some point, something is going to be captured. I think it really comes about architecture. I mean, obviously, if you're worried about something being stolen, putting it into a system that obviously communicates and calculates is probably not the greatest solution. So you would develop your own ad hoc solution that can be localized and, trained for your application. But I think, the legal precedent is going to be set very clearly through the class action lawsuits. And then by extension, it's going to start to protect the data. And that's what I imagine. So any standard practice, I would assume, and then whatever comes out of litigation. Awesome.
Hello. I just wanted to know how many times you went through like iterations of that prompt that you showed earlier with the bar drinks because of how detailed it was. Like, I'm just wondering how many different iterations you went through.
One.
Only one?
Yeah. We wanted to show, like, it's just one of those things. Well, so here's what I'll say. When it came to guiding the prompts and just fine tuning it, we had the original idea pretty close. We modified the verbiage 3 times, I think. But as far as getting output, I just grabbed the first one that came out just because I wanted it to be contextually relevant and not, cherry picking, doing like 3 pre-rendered video game footage,
we had to put some guardrails on the prompt because oftentimes there would be this text that would appear on the label or something in the background that was just gibberish. And so by massaging the prompt, we were able to eliminate the text from the output. Almost. Are we 100% now or no?
I don't think you're ever 100%, but it's close.
Yeah, no, I gotta imagine that part is hard. Just like, because I mean, even just using it, like you're saying, you got to be really, really specific with what you get. So that's really cool.
Yeah, the one thing that I would say is any text that's in the input, it will use. So if you don't want text, if you use words like text, you're probably going to get text. So I've had good success if I'm trying to develop like a logo. If I use icon, a lot of times it'll take out text. You really just have to play with it. And, I like to think of it as it's not random, it's chaotic, where if you knew exactly the parameters, you'd be able to correctly predict the output. It's just we don't have access to the chaos. So you just kind of put in the input and just hope you get a good output. If not, you just do it again. So,
and what was interesting, some of the learnings that we took away from prompt drinks and just kind of going through the process of building this out is the ability for it to actually be creative with its output, where you have the guardrails to prompt, the codex and say, okay, this is what we want, but we want it contextually relevant to wherever this output is going. And so in this case, promptdrinks.com, it's going to be a cocktail, it's going to be ingredients and instructions on how to make it. But you could type in on the input any string of text, like any character, you could say whatever you want. And that's when you really get to see the creative output, where it'll take your input and it could just be like, I have a headache. And then the output will be something about a headache cocktail. And you read it and you look at it, you're like, that kind of makes sense. There's a lot there that is creative in its own way. So it's been fun. And that's just one example. And so you can imagine what kind of environment you want the output to live in. And that's where the prompt engineering goes. So you say, okay, no matter what, the output's going to be contextually relevant to this environment. And that's pretty cool.
Yeah, to touch on real quick, I completely forgot. I probably should have put it in here, but we did Harry Potter characters as drinks, and it was pretty bang on, actually. It was hilarious. So you have access to it. Maybe give it a shot. Obviously, the training data isn't super current, so keep it, 2.5 years back, but it's really interesting.
So I was just wondering, you mentioned a little bit about the charging and how ChatGPT 3.5 is like a lot cheaper.
Mm-hmm.
I was just wondering exactly how that billing process goes down, like how you're charged for it, because I saw your await function. So I I was wondering if they charge how many calls you're making to their API and all of that stuff. And I was wondering kind of if you've looked at the numbers and saw, like, is this, financially viable? Like, how are we going to do this? Because obviously you're picking a cheap version for something like this. But if we're making a big business off of using OpenAI's model, is this worth it financially? Or are we going to end up paying a big bill because of how many people are putting in prompts?
It's worth it.
Yeah. Yeah.
So
I mean,
we're subsidizing bandwidth consumption costs in the form of tokens and paying OpenAI every month with advertising revenue. So we did some model. We ran the numbers, and at scale, there's margin for our system and for our clients.
yeah. And just to kind of touch on, it doesn't matter per request. It's all token based. You can specify max tokens though. So obviously if you set a super high max token, you can eat into that and end up paying a lot more. It really just depends. I know this is such a crappy answer, but it's, kind of the how long of a piece of string do you need situation where, depending on the needs of the business, there are other solutions that you could use that might better fit. So you have to analyze how much it's going to cost at scale. I mean, right now, OpenAI is taking a massive, massive hit. And it's not going to be that way forever, which is why I'm bracing myself for the pricing tiering, because right now they're basically taking your data, right? And that's how they're making. I mean, they're losing money hand over fist in processing power, and they're scrambling to get the hardware to be able to run this because there's just so many people running this. So it really just comes down to usage. Obviously, Dolly is pretty expensive as well. So when we were projecting costs, Lambdas waiting for a little bit are a drop in the bucket, comparatively speaking, in, gigabyte seconds versus paying for a prompt. And I imagine those will go down and you can fine tune models. And there are other players in the space that you could take a look at maybe, but hopefully that answers your question, at least with some degree. So
OpenAI limits you. It limits your access, and there's different tiers based on expected volumes. Like, what do you use? So our application process was pretty straightforward. What are your intentions? Like, what applications are you building? Give us a demo. Who are you? Where's this going? And so you apply, you get approved, and then you can hit the endpoints, you can test, and then you can scale up to the limit, and then you reapply for a larger limit, and then you kind of gradually grow whatever your application you're building, you can grow as long as you stay ahead of the cost, because it could get pricey. If you don't specify for Dolly, each image is going to be pennies, and at scale it's expensive. So if you're not monetizing that image that you're outputting, you're paying for it.
Yeah,
so
definitely ROI centric. All right.
Anything else?
Anybody else?
Oh, we got one more.
Cool.
We got time. You guys
I
are
know.
doing
I was
good.
gonna say. Doesn't matter the question. Any question.
I
Favorite
just
color is
can't
purple.
wait to kick you guys out of here.
I know.
Is there any potential for weird prompt injection or anything different than you would see in normal kind of code bases or anything, like any weird edge cases?
Can you specify a little bit?
I guess just getting the model to do something really unexpected, since essentially it's like a black box, right? Like you can't see inside it. So
Yeah, I would say, I think the power of an LLM is the fact that you have such giant data models that it's fairly good at predicting what a successful outcome is. They have the lower tiers, like Ada and Lovelace. Those ones get a little dicey, but depending on your expected output, sometimes having a little chaos is totally fine. We found with DaVinci and now 3.5 Turbo, we don't find a lot of outliers as long as you are granular enough with your description. And we certainly don't count on the user to provide that level of detail. We guide around it. So even though the user input could be 1 or 2 words, we'll have a scaffolding built around it that contextualizes it for our use case. So I'm sure, I can't say with certainty that we would get some kind of a weird outlier case. I just haven't seen it yet. I don't know if that answers your question.
So if they wanted to essentially negate what you had wrapped around there, is that something that you're able to prevent, or is that a concern at all?
I wouldn't say it's a massive concern, especially depending on how you scaffold this out, right? This is if this were howtogivecpr.com, then I would be a lot more worried than prompt drinks, because I'm the type of person that if I saw a drink, as long as it didn't say like radiator fluid or something in there, like, I'll try it. Let's roll the dice, right? Let's see if it's, let's see if it does well. But certainly there are guide rails that you would have to do based on what industry you're in or what the level of trust has to be. But that's with anything, right? You have to understand how the user is going to use it and understand how they could potentially abuse it and what potential harm it could create for your end users. So you either limit the scale or scope of your site, or you clamp down on, or you add, third-party monitoring, or there's a million ways that you could skin that proverbial cat.
Yeah, and the safety scaffolding that Microsoft and OpenAI implemented is pretty rigid. They have a lot more to lose with crazy outputs. So they've put all the safety measures in, and they monitor the outputs, so they won't let anything get out that, could jeopardize OpenAI in any way.
Thank you.
Yeah, for sure.
This is our last one, but after this, if you guys have any questions for the guys, please hit them up in the hallway. I'm sure they'd be love to chat with you.
Heck yeah.
Just a quick question: if y'all have played with Facebook or Google counterparts to Microsoft's, acquisition, and if you had any experience or thoughts on that.
Yeah. So to specify, probably Llama and Bard. Yeah. So I don't have a ton of experience. I know I tried to get into Bard, and I had a bunch of problems, and then I read that they had to turn it off for a while because it went rogue again. Not scary at all. I mean, it's fine. They killed it before it got too many of them in the lab. But yeah, but it's one of those things where there's always going to be an ethical gray area. And I guess the closest that I could say as far as AI, just to touch on this a little bit, everyone was worried about the car, where's the horse going to go? Everyone was thinking about making a faster horse instead of a car. And I think AI is the next evolution. And I know Google and Facebook are going to get there. I've read that there were some problems, and even just me trying to get my hands dirty, didn't have a lot of luck. But I mean, I think a week ago, they finally released, finally fully released it. So hopefully I can get it.
We're on the waiting list for Google's AI for BART, and we will integrate and test and just kind of measure, performance compared to what we have going now. So we would like to be, API agnostic with the AIs, because it could make sense to hit that endpoint versus, our, GPT-4 endpoint. So we'll see. It's so new that we just don't know how that performance is going to look for us.
Yeah, a little less stability on those two right now, I'll say.
All right, guys, let's give him a big round of applause. Thank you so much. Joel and Ken, that was awesome.
Yeah.
I will say, this is when Ken was like early on, he's like, Sean, oh my God, I got to do something. This is amazing. And we were at a bar, and he had the most early prototype of just playing around with what we could do. And we were at a bar, and you and I were literally like let's try making a drink. And we made it, and we told the bartender, can you make this drink? He's like, I've never heard of that. We're like, oh, well, we made it in this app. Seconds from that, we had the bartender, we had the guys up on the other side because we were all like, and these guys on the other side of the bar were like, those guys are having fun. Let's buy them a drink. Then we told them what we were doing. Everybody in the bar was making drinks with this app, and we were dying because people were losing it. And I just saw the potential. It was really cool.
We started with prompt drinks so we could do QA in the bar. So we're like, we have to go test our app. So let's go.
This is work billable.
But yeah, it was fun. I think everyone was excited to try it, and
And this was like right before it really blew
and
up
the
too.
bartenders loved it too.
Oh, no.
because Some of the ingredients were kind of out of left field, where they're like, "What? We would never make that," but they're like, "Let's try it."
The shots weren't bad.
After a few of them, it tasted all right.